Welcome to The Explainer. Today, we're going to let you in on a secret that's been hiding in plain sight. You know all those different formulas for the area of a triangle, a parallelogram, even a circle? Well, it turns out they all come from one simple idea, the humble rectangle. And once you see it, it'll completely change how you look at geometry. So, let's start with a really basic question. Just look at any flat shape, anything. How do you actually measure the space inside it? It's not about how long it is, right? It's about the surface it covers. And that's exactly what this whole concept of area is for.
All right, so first things first, we need to get on the same page. What exactly is area?
Okay, this is really the key. If you want to measure a line, which is just one dimension, you use a one-dimensional ruler, right? But for a flat surface, for a two-dimensional space, a line just won't cut it. You need a two-dimensional unit to measure two-dimensional space. And for that job, our go-to tool is this, the mighty unit square.
And that leads us right to the core definition. The area of any shape is, well, it's just the number of these little unit squares you need to perfectly cover the whole thing. No gaps, no overlaps, just a perfect tiling of squares. That's it. At its heart, finding the area is really just about counting squares. So if it's all about counting squares, well then one shape becomes the absolute king, the cornerstone for everything else, and that's the rectangle.
I mean, just look at these two. We could literally sit here and count every single square inside them. For the brown one, you'd count 1, 2, 3, all the way to 12. For the gray one, you'd get 9. This is area in its purest form. It's just counting.
But let's be honest, counting one by one, especially for a giant rectangle, would take forever, right? So we figured out a brilliant shortcut. Instead of counting every single square, we can just multiply how many squares are in the bottom row, the base, by how many rows there are, the height. That whole base times height formula, it's not some random magic rule. It's just a super fast way to count the squares.
And this is the part you really gotta get. The area of a rectangle isn't just one formula out of many. Nope. It is the key idea. It's the foundation that pretty much everything else in geometry is built on. Once you truly get this, the rest of it just feels like playing a game.
So let's play that game. Our goal from here on out isn't to just memorize formulas. It's to see every new shape as a kind of puzzle that we can solve.
All right, check out this parallelogram. It's slanted, kind of awkward. It's definitely not a nice, tidy rectangle. But what if we could rearrange it? What if we could chop it up and move the pieces around? How could you turn this into the simple rectangle we already know everything about?
Well, the solution is just so simple and elegant. You just slice off that little triangle from one side and slide it right over to the other side, where it fits in perfectly. And boom, just like that, you've got a perfect rectangle. And notice, the base is still the same length. The height hasn't changed, so the area, the number of squares inside, has to be exactly the same. We didn't need a new formula, we just saw it as a puzzle and rearranged it back into a rectangle.
Okay, so what about a triangle? Let's start with the easiest one, a right triangle. I mean, you can see it right away, can't you? It's literally exactly half of a rectangle, so its area has to be half of that rectangle's area, 1/2 of base times height. See? No new ideas needed. But what if you have a more, wonky triangle, one that isn't a perfect right angle? The same idea still works. If you draw a rectangle around it, you can see that the triangle takes up exactly half of that rectangle space. The other half is filled by those two smaller triangles on the sides. No matter how you slice it, a triangle is always half of its bounding rectangle. It always comes back to base times height. All right, so shapes with straight sides, we've got them. We just treat them like puzzles. But now, for the final boss, a shape with no straight sides at all. This just seems like a whole different beast, doesn't it? A circle has no corners, no straight edges to slice off and move around. So how in the world are we supposed to turn this into a rectangle? Or maybe we can. Now this is one of the most beautiful and clever ideas in all of math. Watch. You slice the circle up into a bunch of tiny wedges, like a pizza. Then you take those wedges and line them up, alternating them, one pointing up, one pointing down. And what's crazy is, the more slices you make, the thinner they get. The more this new shape looks, well, it looks almost exactly like a rectangle. So let's look at this new rectangle-ish shape. What's its height? Well, it's just the length of one of those wedges, which is the distance from the center of the circle to its edge. We call that the radius, or r. And what about the base?
The base is made up of all the little curved edges, which is half of the total way around the circle, or half the circumference. The full circumference is 2 pi r, so half of it is just pi r. So now we just do base times height. That's pi r times r, which gets us the famous formula, pi r squared. How cool is that? Even a circle is basically just a rectangle in a clever disguise.
So let's tie all of this together. What's the one big idea that you should walk away with from all of this?
Think of this as your new mental toolkit. First, remember that area is just counting squares. Second, learn to see every complex shape as a puzzle you can break down and rearrange. Third, always use what you already know, the simple rectangle, to figure out what you don't. And this isn't just a trick for geometry class. This exact same idea, breaking a complex, curvy thing into an infinite number of tiny, simple rectangles, that's literally the foundation of calculus.
This really says it all. Look, by all means, memorize the formulas. They are incredibly useful shortcuts, for sure. But the real power, the real aha moment, comes from understanding why they work. When you can see that it's all just a game of rearranging puzzles to make rectangles, then you've actually mastered the concept, not just the test.
So I want to leave you with this one last thought. This whole strategy, taking something big and complicated and breaking it down into simple, manageable pieces that you already understand, that doesn't just work for shapes. So what other big, complicated problems in your own life, in your work or your studies, could you solve if you just found the right way to slice them up?